Throughout this course, I've favored the Fluent API for configuring mappings that don't align with EF Core conventions. I did mention early on that there is another way to configure mappings called data annotations, and I wanted to be sure you at least got a quick look at them. But first, I should explain why I prefer the Fluent API. All of the possible mappings are defined in the Fluent API, whereas only a subset are available as data annotations. The second is that I personally do not feel that my domain classes should have any awareness or any care in the world about how or where they'll be persisted. And because of that, it makes no sense to tell those classes about how to map to the database. A third reason is so that I don't have my mappings scattered across multiple entity classes, as well as some in the DB context. With all of my mappings in one place, I have better code readability and maintainability. But data annotations didn't start out for use with EF Core. ASP.NET already used some to help with user interface rules for ASP.NET MVC. In fact, here's some documentation for ASP.NET 4, where you can see annotations being used to apply rules to properties, and how the validations are surfaced in the user interface because of those annotations. Entity Framework took advantage of the existing ones, then added a few more and used them for building the data model. In fact, data annotations exist within the System Component Model Data Annotations namespace, and then those that are specific to EF Core are in a sub-namespace of that called Schema. That means you don't have to add EF Core into your project just to support the annotations. Here I'm using the column annotation to change the column name of the title property to book title. Data annotations are applied after EF Core infers its conventions, but before the Fluent API mappings are applied. If there are any redundant mappings, the Fluent API will override the data annotations. One last point about these annotations is that they're ignored by the compiler. Like the Fluent API, EF Core will read them for migrations and at runtime, but the compiler won't pay any attention to them outside of not having a proper reference for them or just misspelling them. EF Core has support for storing data as JSON in your database. This first arrived in EF Core 7, was enhanced in EF Core 8, and will continue to evolve. While it's possible to just have a string property in your class and set its value to a JSON string, the mapping support is far superior. Here's one flavor of the support. Notice that this contact details type has an email address property and a phone property, but there's no key value, and therefore it can't be an entity, but it can be used as a property in other entities as I'm doing here in the author class. There's a specific mapping you'll need to implement in OnModel Creating to enable this, but with that in place, the contact details data will be stored as JSON in a char field in the database, as you can see here in the screenshot of the author's table data. The benefits of this mapping over just using a string property with JSON in it is that it lets you express queries that involve the properties of the type that's being used, and you can also do updates to individual properties. Another benefit to the support is that it allows EF Core to finally be able to persist collections of primitive types. And by primitive types, I mean scalars that EF Core already knows how to map to a database type, like strings and ints and date-onlys, etc. There was no way to do this prior to the JSON support. So imagine you have a property that's a collection of strings, like this nicknames property that I've added to author. In code, you can interact with it just as you can with any other collection. For example, in this bit of code, I'm setting the value of the new nicknames property to a list of strings. EF Core will transform that list into a JSON string and store that in a char column in the database. And you don't have to explicitly map this. It's a convention based on seeing that collection of scalars. While EF Core supports this for all providers, each provider may have their unique way of storing the value. One of the mapping features in EF Core that I'm really fond of is called value conversions. EF Core is dependent on its underlying ability to transform .NET types to common database types. But sometimes you need to do something a little different. My favorite example is storing color data, which in .NET is a struct. And there's no color data type in any database that I know of. So developers have always had to do their own transformation code. The various colors aren't even values. They're different properties of the struct. So you can find a lot of threads on places like Stack Overflow asking for advice on how to transform a color struct when you're using EF Core. As EF Core evolved, it gained a super cool feature called value conversions. There are some built-in conversions that are easy to reference, and you can write your own. I'll show you some examples. First are the built-in converters that are triggered in the same way that you map any property using the Fluent API, with a method named hasConversion. In fact, the ability to store enums as a string is one of those built-in converters. I can store those book genres as strings by referencing entity of book and its property book genre, and then using the generic syntax of hasConversion, I can say hasConversion of type string. Then, when EF Core is saving that property, it will persist the string that represents the item's name, and when you query, it will convert it from the stored string back to the enum. You can find the list of built-in converters in the EF Core docs. All of these converters inherit from a converter class, so you can create your own classes, but there's also a handy shortcut where you can feed the logic for the needed conversion during saving and the logic that it needs to convert from the stored data back to the .NET type when you're querying. It's important to understand that you're not converting to a data type. You're converting a type that doesn't have a mapping into a type that does have a mapping, and then EF Core knows how to store that in the database. And on the way back, EF Core transforms from the database to a type it knows how to map to, and then your code converts it back to that unmappable type. And here's what that looks like for my favorite example, ColorStruct. As the parameter for hasConversion, I now have a pair of lambdas, where I'm specifying my own variable names. The first operation takes C, and to me that just means color, and I'm saying convert the color struct using the struct's toString method. On the way back, I know that there's a string coming out of the database, so I'm converting it back to a color struct using the colors_from_name method. I highly recommend checking out the docs for conversions because they show so many interesting and helpful ways to use this feature. Quite often, we want to apply a mapping or conversion across the entire context for every property of a particular type. You can apply configurations and conversions in bulk instead of doing that one property at a time. dbContext has a virtual method similar to on model creating called configure conventions. This feature is referred to as pre-convention configuration. So rather than overriding conventions, you're in fact adding your own conventions. Before I start adding these configurations, I do want to point out something about these virtual methods in dbContext. Configure conventions, on model creating, and on configuring. When you use Visual Studio shortcuts to add these virtual methods, they always have the base call inside the method. But you may have noticed that you haven't seen that in any of the code samples that I've shown. These methods are referred to as no-op or no operation. If you look at the code in EF Core's repository, you'll see that configure conventions and on model creating and on configuring are all empty methods. So these base calls that get added to your code do nothing. There are reasons that they stuff that line in there, but that's getting out of scope. But that's why you never see them in my code and why I'm about to delete this one. The configure conventions method provides a configuration builder object from which you drill into its properties, and those properties refer to any and all properties in the data model. And it's generic, so next you specify what types the mapping should focus on. For example, all strings. And from there, you have access to pluralized versions of the property mapping methods. For example, instead of hasColumnType, here we have haveColumnType. And these methods take the same parameters as their singular counterparts. So if I want to have all of my strings stored by default as varchar 100 instead of SQL Server's default of nvarchar max, I can define that here as configuration builder properties of type string have column type varchar 100. Additionally, there's a bulk version of hasConversion, and that's called haveConversion. With that, if I have multiple classes that use the book genre enum and I want that to always be stored as a string, I can use HaveConversion to do that instead of adding a mapping for every one of those properties. However, if you've created a custom conversion, the shortcut I showed you before won't work with bulk conversions. The reason for that has to do with an advanced feature for pre-building the model that I'm not covering in this course. So if you want a custom conversion that applies to many properties, you'll have to create an explicit value converter class and pass that into the HaveConversion property. You can see more about how to do this not only in the EF Core docs, but in my Code Magazine article called EF Core 6 Fulfilling the Bucket List, which I'll link to at the end of this module.